Okay, so today we will talk about products that Dell used not to be very aggressive, very active with, which is unified storage. So as you know, before we used to work with certain storage partners, and now in recent years, Dell has been increasing the number of products based on its own intellectual property. And I think some of you, as we have seen, have already experienced very good results with Dell products and technologies. So today I will share with you a little bit about Dell Unified Storage. So we'll see a little bit about some data management challenges and opportunities that solving those challenges brings about. We will see how fluid architecture solves these challenges through unified storage, and we'll take a look at our FluidFS portfolio, and then see a little bit about features and capabilities. Throughout the presentation, if you have any questions, or at the very end, you can raise your hand and ask questions. So the challenges, actually, we know they haven't really changed that much in the past 10 years. Storage has already been growing. People complain it's too expensive, or it's very expensive. So currently, it's about 20% of infrastructure spend goes on storage. And we can see that at least abroad, labor makes up a large large proportion of OPEX. So that is something that companies are trying to cut down on this cost of managing ever-increasing amounts of data. So the digital universe, the amount of digital data in the world is increasing very fast. So according to different research reports, we can see that it's doubling every 18 to 24 months. And then the majority of this growth is coming from where? It's coming from unstructured data or files. So this is where it's coming from. Of course, structured data or databases is growing as well, but not as fast. So we can see this according to one report. The amount of unstructured and structured data in digital form available worldwide today is about 42 exabytes, estimated 42 exabytes. And then according to another research, oh, by the way, so this is usually types of files or unstructured data that is considered unstructured. Some people consider mail to be semi-structured data because you have header, you have date, sender, recipient, etc. But then if you archive it off to an archive, you could also call it unstructured data because a single email is available in its elementary form. But anyway, then we have normal documents and various multimedia files, images, videos, music, etc. So according to another research, you can see here that this is by IDC. It is estimated that, it's not green, it's gray actually, but it is estimated that the amount of unstructured and structured storage stored worldwide will increase to 80 exabytes. So we can see from now, 2012 to 2014, we will have twice as much storage as we have today. And then you can see here that the aggregate growth for unstructured data is close to 60% a year versus about 27% for structured data. So apparently we need ways to manage this challenge better, to have system administrators and storage administrators who are capable of doing their jobs faster, cheaper, more reliable, with less human or pilot errors, as we call them, and to allow enterprises to derive and extract value from all the data they store on their storage. Now, how does Dell unify its storage to this fluid data architecture? So a few years ago, when the management started thinking about these coming changes and these trends, one of the things that came to their mind was that we wanted to have a way to provide scalable solutions to address this rapid growth of unstructured data, while at the same time not changing users' habits of managing proven and popular Dell solutions and storage brands such as PowerVault, EqualLogic, and today, of course, Compellent as well. So we wanted to provide unified storage in which capacity is available to storage administrator to provision it every which way they want, be it fiber channel, block devices, iSCSI, block devices, fiber channel over Ethernet, NFS, CIFS, all these things depending on their needs. All right, so this was one of the main objectives for Dell's future unified storage. This slide you have seen, I think, before, so I will just mention a couple of important things. Oops. All right. So throughout the portfolio, all these little circles with the letter F, this is where we intend, and we have already started doing this, add scale-out storage for file serving and unstructured data integrated with our existing product lines to provide unified storage and scale-out capability to all Dell storage families, from PowerVault all the way to Compellent. So this is the vision to provide through Fluid Data. Now, while doing this, we have looked at the ways people have done unstructured file serving, unstructured data serving before. So we all know traditional NAS, what it is. It's been around for about 15 or so years. And then it normally consists of servers based on monolithic design. They do not scale out. They scale up. When you need a bigger one, you buy a bigger box. Now, they're all nice and they have enterprise features. But the problem is, as data is growing rapidly, you either have to engage in buying many of these smaller boxes or servers, NAS servers, or ever changing and spending a lot of money to keep up with the data growth. But even if you keep up with the data growth, usually they scale in capacity, but less so in performance. Now, in recent, since maybe 10 years ago, we also know that clustered file systems or scale-out storage for file serving has been getting popular as well. Initially, what was very specific to these systems, that it started off from the HPC, high performance community. So they tended to use proprietary protocols because in certain cases, rather than settling down on the least common denominator or some standards such as NFS or CIFS, the researchers, they thought they might extract every single bit of performance out of their hardware by using proprietary protocols. For example, one cluster file system, scale-out cluster file system that's been very popular, the basic standard in HPC is Lustre. As we know, Lustre primarily uses the Lustre client, its own client. Now, with these systems, the problem is, number one, management. They used to say you need a PhD degree to be able to manage those, configure and manage those boxes. And also, they are very complex in terms of troubleshooting and maintaining. And they lack a lot of enterprise features. For example, we know that a lot of these systems, they do not have POSIX capability. So they do not support standard Unix file system syntax. So if you want to use them in certain applications, such as maybe Oracle or something like that, they won't work. Now, of course, the idea then is to combine the best of both worlds and get products that scale out, but at the same time, they're simple to use. They offer standard-based protocols and provide enterprise-class features, by which we mean things like very good snapshot implementation, ability to integrate with existing backup solutions, etc. So this is where FluidFS comes in, and this is where Dell settled on the FluidFS technology. Now, some of you might know that FluidFS technology Dell acquired in 2010 from an Israeli startup called Exanet. And since then, we renamed it. The basic stack looks like this. So we can see it's not a single part of stack that fits somewhere on a Linux box and does one thing or two. It's an entire solution, and we will now just briefly browse through all these main components of the stack. So at the very top, you can see the clients they face, when they face the system, they use TCP/IP to connect. So on this layer, not only do we perform and support the typical round-robin load balancing, but we also can perform even better load balancing based on least, by sending clients to the server with least number of connections. And then even within that server, if it doesn't use LACP bonding, so if we use ALB or if we use individual IP addresses, it can then redirect the client to the port with least CIFS connections. So it performs very nice load balancing on the fly. Then, of course, the same stack is also in charge of performing failover. After that, we provide NFS and CIFS standard file serving protocols. Below that lies the key component, FluidFS distributed file system, which is an extremely scalable file system for parallel access. When I say scalable, I mean both in performance and also in capacity. We'll see about that a little bit later. And then underneath, we have a patent caching technology, which takes advantage of memory in these servers to provide better performance, protect data, ensure less fragmentation, and perform certain other things. We'll also talk about that a little bit later. And then finally, we have excellent snapshots implementation that is in line with industry-leading snapshots, which is redirect on write, which is a very space-saving way to take snapshots, and also does not incur penalty on performance. And finally, high availability is not also some bolted-on set of scripts. It is integrated throughout the whole stack. So all the way from a customer or client-facing network layer all the way to storage, we monitor services, status of all components, and perform failover and failback as it is required. The architecture, of course, looks familiar. Anyone who has used NAS before is familiar with this picture. So we have clients on the client network which use CIFS or NFS. They approach through a switch and connect to these FluidFS NAS clusters. And then behind them, we have different Dell storage families, EqualLogic and PowerVault at the moment. Now, we can see here that these Dell FluidFS NAS, they're deployed in pairs. So this is how we ensure high availability and how we protect data and service. One thing that I mentioned about cache is, I think, quite interesting and not frequently seen, is that we perform write cache mirroring. So all the files that client sent to either of the nodes is first mirrored through the interconnect to the other node's memory. And then we tell the client, your file has been received. And then the file, we actually write it to storage when we see fit. But even if any of the nodes crash, then if that node crashes, the other node will know, and it will still be able to commit data to backend storage. So we use memory in a way that's not so common for file serving. Of course, we know that storage disk arrays such as Compellent and EqualLogic, they do cache mirroring because those are blocks. You really have to mirror your controller cache. But for NAS file serving, it's reasonably rare. If you look, most even scale-out storage that is popular today, or file serving clusters that do not perform write storage mirroring. At most, what they do not commit file system journal until the file has been written. So if your server crashes, you will lose the file, but the file system will remain free of corruption. So this is something very nice. And then, of course, we perform load balancing based on those algorithms I mentioned before. On the back end, of course, we support, currently we have products that support both PowerVault and EqualLogic, and a Compellent version of FluidFS NAS is on the way. Now, in case I want to scale out, for example, my network capacity is not enough, I need more performance, I can add another pair, and then in case I need more capacity or I need more IOPS on my storage, I can add another enclosure and another type of disk or same type of disk to my disk array. So Exanet, they used to have far larger clusters. Right now, we don't build clusters larger than what you see on the picture, but we will certainly, as customers get more data and request more scalability from us. There's no limit in the architecture by itself. So what have we done so far? So some of you might have seen our current products, but let's take a quick look. On the SMB, in the SMB space, scale-up storage, we're using the regular Windows storage server-based NAS, and this is normally targeted at customers, Windows-centric shops, or customers with smaller needs. For anyone who has larger needs, we provide FluidFS packaged in 2 products so far. So one is the NX3500 that connects to PowerVault, the iSCSI version of PowerVault disk array. And then the other one is EqualLogic FS7500 that can be used with any EqualLogic array that was ever released, as long as it has a firmware version that's newer than 5.0. And then, of course, the high end at the very end, we have Compellent, which does have unified storage right now, but it is not yet based on FluidFS. So let's see how these solutions look like. The NX3500 one we have for PowerVault, this system, actually, this is how it looks like. So it is a very nice way for existing customers and new customers who do not need extraordinary amounts of data. They need a basic setup, not too big. And we have this cluster which occupies 3U space. The server itself leverages the PowerEdge 310 server, and then 2 of these servers make up a cluster. At the very bottom, what you see here is what I mentioned, a backup power supply, which is a dedicated battery-backed unit that can provide power, so in case power goes out, these servers can still have enough time to either commit all the pending writes to backend storage, or if backend storage by some case goes down, they can save it locally so no writes will be lost. So this is how this unit looks like, and currently we support 1 unit with 1 PowerVault system. We know that PowerVault currently scales up to 192 hard disk drives. If I use 3 terabyte nearline SAS, that would be 576 terabytes raw. Now, I will not use RAID 0, obviously, that's kind of crazy, but I would use RAID 6 with maybe 10 plus 2 and some hot spares. So this would give me about 380 terabytes maximum capacity for 1 of these systems. So all the enterprise features that I mentioned before, they're all bundled with the system. So once you buy this unit, all these features of snapshots up to the tested limit, asynchronous replication. If you have another system, you can replicate to that system. And then NDMP backup, NFS CIFS, all these things are included and require no extra licenses. So this is the first product. And then the second one, the first one we launched last year in May. So that was the first launch. This one, FS7500, the EqualLogic model, is similar, but unlike the previous one, it can scale to 2 systems. So you can go up to 4 controllers with this system at the moment. It also contains all the great features, and this is the major step in expanding EqualLogic while keeping the same user-friendly interface, the same licensing model, all-inclusive software delivery model as EqualLogic. So it works along existing features. It uses the same GUI. So once, if you buy the system, you connect it to EqualLogic Array, you will not have another GUI. You will not have to create LANs on EqualLogic and then operate them on NAS. No, you will, EqualLogic GUI will recognize the system. It will configure it. It will add it or join it to AD if you need to. And then you can create shares directly in there. So it's completely integrated and allows users to decide whether they want to allocate EqualLogic capacity to file serving or to block serving, Oracle, Exchange, VMware, Hyper-V, or whatever they might have. So this is the beauty of this system, and it scales up to half a petabyte, so 509 terabytes in 1 cluster. Compellent, a MENAS for Unix and Linux-centric customers. So these work in a unified way as well. When you have these systems with Compellent, you do not create LANs presenting to these systems and then manage those systems separately. You go there, you create shares. The system uses Compellent API to create LANs, present them to these systems, mount them, and do everything for you. So it's already available currently in these systems. Each server is 1U rack mount server that boots from SAN. If you want high availability, you can buy 2, and they can then perform failover in an active way that is common among Windows storage servers and general failover clusters. So it's not scale out, but it's unified, and we've been shipping it for a while now. We have planned, and we are actively working on creating a Compellent version of FluidFS NAS, and it's going to come out soon. So we'll have even more choice. But then it will all be aligned. We'll have Windows storage servers. Still, we'll keep those available. But then the unified storage vision of FluidFS, it will be available across all Dell storage brands. Okay, now the features. Of course, features are many. I will mention just some that I think are quite interesting and maybe unique to our products. If you have any questions, of course, you can ask for clarification. So, single distributed file system. When we say single, we mean that all the storage that you allocate to NAS from a Dell storage product, it all gets formatted with a single file system, and you do not have to worry about asymmetric design or certain file systems being more overloaded, and then you have to manipulate file systems to migrate data, such as some of our competitors do. So it's a single file system, and then all the nodes are peer nodes. There's no master or metadata controller, so it's very easy to manage them. When you manage them, you do not pick where I want to put my data. You just create your virtual file systems, and all data is sprayed across all of the LANs in the back end. Another nice thing is there are no artificial limits in the file system. We do publish tested limits, what we test in the lab as part of our QA, but these limits are very large. For example, total capacity. Right now, you've seen we support up to 509 terabytes in the FS7500. With Compellent, we'll support even more. So those are capacities that we test. But, for example, file size, some vendors up to a few years ago used to have maximum of 2 gigabytes. Now they can maybe support 2 terabytes. We support 4 terabytes. Number of files on the file system, on one pair of nodes, we support 4 billion files. But even that is a limit of testing, not of architecture. So as you add more, we will be able to support even more. Scalability, like I said, very large number of nodes. Same thing right now, because of the capacity and performance. We don't need really that many, but with Compellent we'll provide more, and then in the future we have plans for even bigger cluster. Virtualization and adaptive behavior. This is also very nice. I mentioned that cache is actually quite an important part of file serving. Normally, with Linux-based clusters, cache is used in the way the system uses it. There is no NAS-specific way of leveraging this cache. With FluidFS, we do that. So how we do that? So first, number one, we postpone writes in order to serialize writes to hard disk drives. So when I have small writes, let's say I write 200 files of, I don't know, 16 kilobytes each or 10 kilobytes or whatever, my FluidFS file system will, actually NASHead will receive these files, it will mirror them to the other node. Once they get to a certain limit and it starts feeling pressure in the cache, it will say, okay, now I will get all these files and in one go, I will write them to my backend storage. So I achieve two things. Number one, I don't spin disks too many times. Out of small random I/O, I create sequential I/O. And secondly, I can write these files faster because rather than writing them one by one or letting it to the OS, leaving it to the OS, and then maybe hoping that it will finish writing them faster or sooner or later, which is a common problem actually both with Windows and Linux. You don't really know when it's going to flush those files. With this system, it does it very smartly in a way that's best for file serving. Then also what we do, we can adjust proportion of read and write cache based on recent behavior. So if your file system workload of this last, I don't know, 10 minutes or 20 minutes tend to have more read cache, we'll actually keep the files longer and expire them sooner. But if we notice that you started writing more and proportion of writes is gradually raising, we will actually destage files to leave space and be able to accept new writes faster. And then another thing is, I think I mentioned it later, but I'll explain it now, it doesn't matter. Another thing with larger files, let's say I have files that are maybe 2 gigabytes or 3 gigabytes or 10 gigabytes, a little bit large files. What I can do, when I receive a file, again, I will mirror it to the other node. I will tell the client I'm done. And then I can even, depending on certain patterns and cache pressure and certain other things, my two nodes that have copies of this file, they can divide their workload. And they say, okay, I will write the first gigabyte, you write the second gigabyte. And then even this first gigabyte, I will cut in 1 megabyte chunks, and I will send one chunk to each LAN. And then the same thing will be done by the other server. So I will completely saturate backend in the best possible way, and I can share this write workload among two servers. So this is how I can use cache, and my cache mirroring protects writes, like I said. In case one server goes down, the other server can commit all these writes without any risk for data. So there is no single point of failure. One graphical view of how this integration looks like from the storage perspective. So normally on any Dell product line, be it PowerVault or EqualLogic, we would have some space that we can allocate for NAS. Other space can be allocated to block devices, fiber channel, whatever I may have. Now, for this space, I don't have to carve up those LANs. Like I said, this is done from the GUI in one go. When I connect my NAS and I create my file system NAS pool, it will automatically determine how many LANs is the best amount of LANs, a number of LANs, and create this space and allocate it to the so-called NAS pool. So once that is done, it will tell me your space is ready. And then I can create my virtual file systems, and on them I create shares. So this is the normal way of doing things. Now, I can create one share across the entire NAS pool, which is less common, or I can mix and match. I can create one, here I can have one on this engineering share, file system, sorry. I can have multiple shares, etc. So this is very flexible. And this also works the other way around. In other words, if I discover my testing requirements have become less, I can actually, in this file system, this share is actually now, instead of 10 terabytes, it contains 5 terabytes. I will actually have some empty space, and I can shrink my file system and then allocate maybe more to marketing or somebody else. So it can also work the other way around. Another thing is that snapshot reserve is done on this virtual file system level. I can set how much space, if any, I want to allocate for snapshot reserve. Now, this snapshot reserve is not the rigid snapshot reserve, as you can see with certain other types of storage, where you allocate 20%. If you don't use it, you lose it. In this way, this is something that's reserved, normally reserved. But then it doesn't really have to be dedicated to that. We'll see about that a little bit later. The cache part, I explained already how it does. So it can use write-back operation to perform faster writing of small files and also faster writing of large files. It is equally good for both small and large files. That's also a rarity, relative rarity in the NAS space. Some file systems are good with maybe medium files and medium to large. Some are good with very small files. Some are good with very large files. This system is good for any, actually. So first, small files are kept in inode space. What we do is, there are different terms for this. One of them is inode stuffing. So our unit of allocation for the file system is 4 kilobytes. If my file, so normally how you do it in a file system, you would write the file name, date, owner, ownership, permissions in something called inode. So this will be information about the file, and the actual content you will write in another place. So if you have a small file, let's say 3 kilobyte file, and your unit of allocation for your file system is 4 kilobytes, I will write inode, maybe 1 kilobyte. I will write it to one block, and then I will write 3 kilobytes of contents in another block. So it will take 2 IOs to write 4 kilobytes of data. Now, what FluidFS can do, if it determines that or can recognize that the file content is maybe 3 kilobytes and my inode information is 1, it can actually get both and put them in one block. So I can save 50% of IOPS when I work with small files. So this is very nice. Number one, it saves 50% of my IOPS. Number two, it saves space. Sometimes when you see, and this is like a lot of people who use regular Linux, they can notice they actually have usable data as maybe 10 terabytes, but they're occupying 25 terabytes on the file system. And this is exactly why. With this one, we actually save. So we don't waste a lot of, we allocate, if we can, only one block to this. And then even for large files, like I said, we will chunk them in chunks and write across all the LANs to prevent overloading of any single LAN. So this also helps with maintaining predictable performance on backend storage. And then also, we perform certain allocation or pre-allocation of read-write cache and also data and metadata cache to make sure that we do not deplete cache space. What happens with Linux also, and Windows as well, like I said, the system doesn't use memory in a NAS-centric way. It just uses memory. So sometimes, let's say if I have, 12 gig of RAM, if I write a 20 gigabyte file, it will exhaust memory for everyone else, and it will just stick this file in the memory. And then your metadata will be exhausted, and you will see maybe, timeouts on iSCSI driver or some service will start, like DNS will start malfunctioning because it cannot handle it. So we do reserve certain space in memory for these critical NAS services. So even under very high workload, the system performs predictably. And then also the integrity. Journaling, it's, of course, very common these days in file system. What does that mean is that you write a file. Once you finish writing, then you create a journal to make sure that this transaction has happened. If your system crashes before you commit it to the journal, what will happen is that your file will be orphaned, so it will take a space on the hard disk drives, but you will not see it on the file system. So that's still better than writing it partially and then not committing something and then it cuts in the middle and then you end up with corrupt file system. So this is what many people do. We do it too. Now we have some extra nice things, which is metadata redundancy and checksumming. So for critical file system structures like file system map, superblock, and certain other things, we will count checksum on those blocks and we will make redundant copies on different LANs. So in case of a corruption, which we can detect by reading the checksum and comparing it against data of this metadata, we can take a copy and replace it to ensure that file system does not get corrupt. And then another thing is that these critical structures, file system map, superblock, and other things, we never update by writing to cache. What I said is valid for everything else. For those critical bits that are maybe a couple of kilobytes per entire file system, for those, well, maybe a couple of megabytes, for those critical bits, we always update them only on hard disk drive to make sure that even there is no any kind of space for mistake. Very important. So because when you have large file systems, maybe 500 terabytes, 1 petabyte, you don't want to run a file system check because it might take months. Now about snapshots. So commonly on Windows, maybe we talk about redirect and write. We talk about copy and write. So copy and write, as we all know, you first copy the block, you put it somewhere else, then you write if you want to overwrite your existing data. So that has certain overhead because you have to read a block, write it somewhere else, and then overwrite it with the new block. We don't do it that way. We use redirect and write. In other words, when you take a snapshot, we point it to a new space, and all new writes will go to new blocks. So there's no overhead. So this is why even with large number of snapshots, you can take hundreds of snapshots per file system or 10,000 per one NAS. We will not feel any overhead from that. So that implementation is well done. And another thing here is I said usually you can say how much I want to reserve. Now this reservation, it's not something that is set in stone and that prevents you from using this space. Actually, as I use this space here, if I'm not careful, maybe I will not notice, I will start using it more and more, then the system will automatically expire oldest snapshots to make space for my data. So I still have time to either buy more capacity or delete some unnecessary files or do something else. So it will help me avoid a situation where my writes stop because I have no space to write them. So in other words, this allocated snap space, it's actually flexible because I don't need to have it firmly allocated because I have redirect and write. And now based on this same technology, we also have replication. So what we do with that, because it's very easy for us to take many snapshots, it doesn't represent any overhead for us. We can take snapshots and we can, on the fly, generate a differential. Because that is so easy, all we need to do is then use TCP/IP to copy those changes to a remote system, and there we will have a copy of our data. So it's very easy, and it saves bandwidth, and it's included in product. There's no extra license that's required for this. We also, during this replication, we take checkpoints while we replicate, and systems, every few minutes they sync. So in case there is interruption in network or something else, they can go to checkpoint between two snapshots and continue replication. So this works pretty nice, and you can see on this picture, this is one of approaches, is two-way replication of different volumes. Site A copies volume 1 to, replicates volume 1 to site B, and site B replicates its production volume for disaster recovery purposes to site A. Protocol-wise, both products support standard NFS and SMB protocols. For CIFS or SMB, we modified it so that locking is done cluster-wide. So if you obtain a lock on a file on one node, it will be obeyed on other nodes as well in the cluster. Integration with Active Directory is complete, so you can join your NAS to Active Directory. And user mapping is, for NFS users, is done via NIS or LDAP. So for Active Directory, unlike standard Linux systems, we also fully support Active Directory, child domains, and trust relationships. So that part of integration is also well done. And then we cache credentials to increase the speed of metadata performance and also to lower the workload that we give to Active Directory when users authenticate against the system. And then in terms of interoperability, Windows access control lists, we support them completely. We save them in native format on the file system, so there's no translation of the file or anything like on the fly or anything like that. And then we also we provide several modes which work on the file system level. I can set my file system to share data in NTFS, centric way, Windows centric way, mixed, or Unix. So if I want to use case insensitivity, I can use the Windows method and just ignore differences between uppercase and lowercase and things like that. So this is very flexible as well. Okay, so a small conclusion before we go to Q&A, if there are any questions. So Dell has realized that by unifying file and space storage, we can integrate our new intellectual property with our proven and successful storage lines to provide the best experience to managing explosive growth in unstructured data. We have so far successfully executed on that vision. Last year, a year ago, launched the NX3500. Last summer, FS7500. Today, these systems have hundreds of deployments worldwide, from Asia to Europe and Americas. We have a strong roadmap for further development of these platforms. And very soon, you will see faster, bigger, and more powerful, more scalable products in this product line and based upon this vision of unified storage. Compelling unified storage with FluidFS NAS is also something that's coming soon. And we can tell you all about this under an NDA because we are not authorized to give you details here. But if you want to know more, please contact any of our colleagues from Dell India, and we will arrange a further briefing. Thanks for your attention. And now, if you have any questions or any experience to share or any problem to share, challenges in file serving, please raise your hand and we'll give you the microphone. No? Okay, well then let's just use, I have a few more minutes. I'm curious, among the public, how many users have NAS that are important, NAS systems that are important in production? So there is one, two, oh, there's a few. And are these NAS systems Windows-based or Unix, Linux-based? Windows-based, raise your hand, please. Okay, so it's like a little bit over majority is Windows-based, and there's some Unix-based. And if anyone wants to share the greatest challenge that he or she is facing right now with file serving, is it the duplication, I don't know, backup, something else? Any volunteers? Backup is one of challenges. Okay. How much data do you have? 13 terabytes. Okay. Yes. So in terms of backup, we have actually several ways. I mean, of course, there are many ways. Sometimes too many, but of course it depends. Not only on Dell, but also on customer environment and their practices. So on these systems, we support NDMP backup, NDMP version 4. But then also what we are doing, we already actually, well, we are working on integrating certain technologies that have not been integrated yet. Some of you may have heard we acquired a company called Ocarina, which performs the duplication and compression. And so this is something that's coming. And also another thing that's coming is that we will integrate the ability to move files from these systems to our archiving solutions. That will also leave you with a smaller amount of data on tier 1 that you need to back up. Whatever is archived, you have backed it up, and it has archive bits, so it's skipped. So we are working on several technologies and integrating existing technologies we have to make this faster and more and smoother for our users. And as you know, it doesn't apply to FluidFS yet, but recently acquired a company called Apassure, which also does continuous data protections for Windows-based NAS. So in case your server is Windows, actually those are really, really nice because they capture data as it's created, so you can restore entire file systems within minutes. So that's another thing that's already available for our Windows storage server-based NAS products. Okay, well, thank you very much. If there are no further questions, then I will revert to FC. Thank you.